Hello, and welcome to this very brief presentation where we're going to consider the difference between parallel and perpendicular lines. Just a brief recap here related to linear functions. Graphs can be represented as functions, and the simplest function is known as that of the linear line or the linear function. It has the form y is equal to mx plus c, where m is the gradient or the slope of the line, and c is the intercept of the line with the y-axis. So considering the graph on the left hand side, we have a line and the equation shown in the form y equals mx plus c. So in this case the m, or the gradient, is 6, which we can see if we take 2 points on the line. Any 2 points are convenient. We work out the vertical distance between the 2 points shown here, and the horizontal distance between the 2 points shown here. We can clearly see that the vertical distance is going to be 50, take away 20, so that's 30, and the horizontal distance we can see is 5 from the x-axis. Then the gradient, the m, is given by 30 divided by 5, which is equal to 6. We can clearly see that the intercept, the c value, is 20. So that's the equation of a straight line. Y equals mx plus c. M is the gradient and c is the intercept with the y-axis. In exercise 3, we're asked to calculate the slope or the gradient of the line shown. So the gradient or the slope, m, is equal to the change in y divided by the change in x. But this time I'm going to use the formula shown here of y2 minus y1 divided by x2 minus x1. The y2 and the x2 relates to the point 2 on the diagram shown here, and the y1 and the x1 relates to point 1 labelled on the diagram here. It doesn't matter in which order we label the points 1 and 2, but those 2 points are convenient points for us which lie on the line. So from the diagram we can see that the y2 coordinate is going to be 4, so following the formula, 4 take away the y1 coordinate is 3, so 4 take away 3 on the top line, and that's divided by, on the bottom line, the x2 coordinate is 6, so 6, and we subtract from that the x coordinate, which is 2. Evaluating, 4 take away 3 is 1, and 6 take away 2 is 4. So our gradient is a quarter, or 0.25. This is a positive gradient. So this graph shows us positive gradients and negative gradients. A positive gradient shown here where m is a positive number, have our direction as shown here. Thinking of walking up a hill when you're moving from left to right. And negative gradients, m is a negative value, have a sense as shown here. In other words, think of walking down a hill moving from left to right. A horizontal line, as shown here, has a 0 gradient, so the y value might be 3, that line might pass through y is equal to 3. Y value, for example, might be 3, the illustration, but the slope or the gradient m is equal to 0. And vertical lines have an infinite gradient, so the m is equal to infinity. So now we're going to consider questions where we're given 2 lines and we have to decide if they are parallel to each other or perpendicular to each other. Let's first consider lines that are parallel to each other. Example 1p. On a graph, parallel lines have the same gradient. So given y is equal to 2x plus 3 and y is equal to 2x minus 4, these lines are parallel to each other because they both have the same gradient, which is a value of 2. 2 shown here and the 2 shown here. So both equations have the same form, y equals mx plus c. The first one, y is equal to 2x plus 3. And the second equation, y is equal to 2x minus 4. Both having the same value of m means that they're parallel to each other. If we consider the first line, y equals 2x plus 3, and plot that on a graph, the intercept with the y-axis is 3, and the gradient is 2 in 1. So we move 1 horizontally, we move 2 vertically to get the second point. So sketching a line, it will look something like this. If we were to plot the second equation, the y is equal to 2x minus 4, then the intercept with the y-axis is at negative 4. So again, the gradient is 1 in the horizontal, 2 in the vertical. Gives us a second point here. So our line will look something like this. And we can clearly see that the lines are parallel to each other. Let's now consider lines that are perpendicular to each other. Example 2p. Perpendicular lines always cross at right angles to each other. So in the diagram below we're given the equation y is equal to 2x plus 3, shown here, and y is equal to negative a half x minus 1, shown here. So to determine if the lines are perpendicular to each other, we multiply their gradients together. If the product of the gradient of the lines is equal to negative 1, they're perpendicular to each other. In other words, the gradient of line 1, m1, multiplied by the gradient of line 2, m2, if that equals to negative 1, the lines are perpendicular to each other. Notice again the lines have the form y equals mx plus c. So in this particular case, the first line has the equation y equals 2x plus 3, so the m1 is equal to 2, and the second line has the equation y equals mx plus c, where the m is negative a half. So multiplying the m1, 2, by the m2, which is a negative a half, produces the value of negative 1. And we can clearly see from the diagram the lines are perpendicular to each other. So just to reiterate, given two lines of the form y equals mx plus c, we multiply the gradients together, i.e. the m values, and if the product of those gradients is negative 1, we have perpendicular lines. Example 3p. 2 points on a straight line are given by the coordinates of negative 4, 9, read that as x, y, and negative 5, 6, again read that as x, y. 2 points on another straight line are given as negative 6, 3 and 3, 0. We're asked to calculate if the lines are parallel or perpendicular to each other. So in this particular question we need to find the gradient of both lines. We're given 2 points on the individual lines, so from those 2 points we can work out the gradient m. I'm going to use the formula we highlighted previously, that m is equal to the y2 minus y1 over the x2 minus x1. So the gradient of line 1 given in the example, for point 1 we're given the coordinate negative 4, 9, and for point 2 we're given the coordinate negative 5, 6. So reading that in terms of xy, the x1 is equal to negative 4, the y1 is positive 9, the x2 is negative 5, and the y2 is 6. Putting those values now into the equation, we can work out the gradient of line 1, m1. So y2 is 6, take away y1 is 9, and on the bottom line x2 is negative 5, and we're taking away from that the x1, which is negative 4. Be careful of double negatives there. Evaluating, we get negative 3 on the top, negative 1 on the bottom, so the gradient there is 3. Now looking for the gradient of line 2, point 1 for line 2, coordinate is negative 6, 3, and for point 2, the coordinate is 3, 0. Again, reading in terms of x and y, that means x1 is equal to negative 6, y1 is equal to 3, and x2 is equal to 3, and y2 is equal to 0. Calculating the gradient of line 2, called M2 here, so y2 is 0, and we subtract from that 3 for the y1, and x2 is 3, and we subtract from that the negative 6 for the x1. Again, notice double negatives there. On the top line we get negative 3, on the bottom line we get 3 subtract negative 6 is 3 plus 6 is 9. That gives a gradient of negative a third. Multiplying the two gradients together, m1 is 3, multiplied by the m2 of negative a third, evaluates to negative 1. In other words, the lines are perpendicular to each other. Here are some questions for you to attempt. Question 1p. We're given 3 lines, stated below, and we've got to determine if they are perpendicular or parallel to each other. So line A is given as y is equal to 4x plus 3. Line B is y is equal to negative 2.5x plus 6. And line C is y is equal to 6 and 4x. Answers are shown in the brackets. Question 2p. We're told that 2 points lie on a straight line. The first point is 5, 5, and the second point is 0, 2. So we can work out the gradient of the first line. And 2 points on the second line, given as 0, 6 and 10, 10. Again, we have to determine if the lines are parallel or perpendicular to each other. Answer shown here. And finally, question 3p. Given 2 points on a straight line are 2, 5 and 5, 11, and 2 points on another line, line 2, are 2, 3 and 8, 0. Again, we're asked to determine if the lines are parallel or perpendicular to each other. Answer shown here. I would encourage you to start the presentation and attempt these 3 questions. The full solutions are shown on the following slides. Question 1p solution. We're given in the question 3 lines. Line A, y is equal to 4x plus 3. Line B, y is equal to negative 2.5x plus 6. And line C, y is equal to 6 plus 4x. So the solution for line A, the gradient for A, MA, is seen to be 4. By inspection of the equation y equals mx plus c, we can see that the m is equal to 4. For line B, the MB is negative 0.25. Again, by inspection of the equation y equals mx plus c. And for line C, the gradient MC, we can see that the gradient is 4. From the equation y equals mx plus c, notice it's written as y equals c plus mx, so the m in this case here is 4. So we can clearly see that lines A and C are parallel, as they both have a gradient m of 4. To find out if the lines are perpendicular, we need to multiply the various gradients together. So consider lines A and B. That's MA multiplied by MB. So in this case that's 4 multiplied by the negative 0.25. That gives us a value of negative 1, so therefore lines A and B are parallel to each other. And lines A multiplied by C, so that's MA multiplied by MC, that's 4 multiplied by 4, that gives a value of 16, so they're not parallel. And finally lines B multiplied by C, so that's MB multiplied by MC, so that's negative 0.25 multiplied by 4. That is negative 1, so the lines are parallel. So we conclude that lines A and C are parallel as their gradients are the same. and line B is perpendicular to the lines A and C, as the product of the MA times MB and the MB times MC is equal to -1. Question 2p, we're given 2 points on a straight line given by 5, 5 and 0, 2, and 2 points on another straight line given by 0, 6 and 10, 10. We're again asked to find if the lines are parallel or perpendicular to each other. So in the solution, again we'll make use of the equation m is equal to y2 minus y1 over x2 minus x1. I'll let you extract the information from the question and determine the various gradients. In this case you will find that when you multiply the m1 by the m2, you do not get -1. So in this particular case we see that the lines are not parallel, as the gradient m1 and m2 is different, and the lines are not perpendicular, as the product of the gradient m1 times m2 does not equal to -1. So the lines are not parallel and not perpendicular. I suggest you stop the slide for a moment and think through where the values have been extracted from. Question 3p, again we're given 2 points on a straight line as 2, 5 for point 1, 5, 11 for point 2, and the 2 points on the second straight line, 2, 3 for point 1, 8, 0 for point 2. Again we're asked to determine if the lines are parallel or perpendicular to each other. So in the solution, again make use of the equation m is equal to y2 minus y1 over x2 minus x1. I'll let you work through the number crunching, a very similar approach to question 2p. What you should find is for line 1 the gradient m1 is 2, and for line 2 the gradient m2 is -0.5. Multiplying the gradients together you'll get -1. So in this case the lines are not parallel because the gradient m1 does not equal m2, but the lines are perpendicular because the product of m1, m2 is -1. Okay, I'm going to leave you with question 4 here. This is actually a question from an exam paper, and within it does involve the parallel perpendicular lines calculations we've shown on this presentation, but it also involves using Pythagoras theorem. So for those of you that want to try the question as written with no explanation, I suggest you stop the presentation now and attempt the question. The answers are shown in the brackets in the bottom of the question. For those of you that would like some further information about how to tackle the question, on the next slide I've added some hints to the question to help you through the solution. So here's question 4, and I've outlined some hints to help you with the solution. The first thing, it states that a lamina is a triangle labelled PQR. So a lamina, definition shown here, is essentially a two-dimensional closed shape. So in our case it's a two-dimensional triangular shape. It's labelled PQR and we're given the coordinates of the points. So point P is 20, 0, read it as x, y. Point Q is 7, 10, again read that as x, y. And point R is 60, 60, again read that x, y. We're asking the first part of the question to calculate the lengths of the sides QR and PQ. Now from your answers, state whether the triangle is an isosceles triangle. So for part 1, the first thing to do is to plot the 3 points PQR on an XY graph. Join the points together and you'll form a triangle. What you'll need to do here is to calculate the lengths of QR and PQ using Pythagoras theorem. From the graph you'll be able to find two sides of a right angled triangle, and then using Pythagoras theorem shown here at the bottom of the slide you can calculate the hypotenuse of the triangles, and that will be the sides QR and PQ. What you should find is they're of the same dimension in this particular case, and if two sides of a right angled triangle are the same, it's an isosceles triangle by definition, shown here in the sketch. This side and this side are the same length. Part 2 of the question wants you to find the midpoint, they've labelled it M, of line PR. That's a question of averaging the y coordinates for the line and averaging the x coordinates for the line. Finally, part 3, we're asked to show that the lines PR and QM are perpendicular to each other. So that's using the techniques we've shown in this presentation. You'll need to calculate the gradients of line PR and QM and then multiply them together and show that the answer is -1. On the following slide I've shown a little more detail related to Pythagoras' theorem, purely for reference. Don't forget that Pythagoras' theorem only applies to right angled triangles as shown in the sketch here. Here is Pythagoras' theorem in terms of the symbols related to the triangle, and this is the rearrangement to find the hypotenuse side labelled C in the diagram here. Here's the reference source on which this presentation was based. I would encourage you to refer to this for further information, and thank you for viewing.